welcome everybody to the EDS Seminar. I'm Nate Porter. I'm the Education Director at Earth Lab and at ESOL. I'm really excited to present or introduce our guest speaker today, Dr. David Whipp from the University of Helsinki. He's going to be talking about geodata science education at Finnish universities, what we teach, how we do it, and what we've learned in the process. I'm going to read Dr. Whipp's background here real quick and then turn it over to him. Dr. Whipp has been a professor of geodynamic modeling at the University of Helsinki since 2013. He completed both a bachelor's and doctoral degree in geology at the University of Michigan. Good to have another Big Ten person in the room. They, prior to working as postdoctoral researcher at the University of Rennes in France and Dalhousie University in Canada. His research interests are broadly in understanding the processes that shape mountains over millions of years, and a common theme in his work and that of his group is the integration of geological, geophysical, and geospatial data with numerical models. He's also passionate about teaching and finding ways to promote the use of quantitative tools and programming in the classroom. Dave is currently visiting CU Boulder for 2 months on sabbatical. So welcome, Dr. Whipp. Thank you.
Great. Yeah, thanks very much. And yeah, thanks for the opportunity to present a little bit of stuff of what we've been doing in terms of developing our geodata science is maybe the right term. It's kind of broad education for geologists, geographers, and others who are interested in basically data that varies in space and time. And we've been kind of developing things over the last maybe 10 years or so at the University of Helsinki. And I guess what I'm going to give today is a sort of overview of what we've been up to. And maybe before I start, I should give you some kind of proper introduction to where I'm coming from, because some of you might not be that familiar with Finland and the University of Helsinki. And I also brought some treats along. You guys are lucky because the first presentation I gave out Finnish salty licorice, which is definitely an acquired taste. These are pretty good. It's black licorice, but they're pretty tasty. So I'll pass the bag around. If you want to try some, feel free. I'll at least take the top off and put that up here. So, so just a couple things about the university. So University of Helsinki's got about 31,000 students in total. So it's not quite as big as the CU Boulder campus in general, about almost 5,000 staff. And our faculty, the Faculty of Science, is the largest of the faculties at the university, with about 6,000 students and 1,300 staff that we have there. So I don't know how it kind of compares to like the natural sciences stuff here. It seems like we have maybe a stronger boundary between certain scientific disciplines. It feels here like there's a lot of interdisciplinary, and I don't know quite how things are divided the same way. But it's a fairly big university in terms of the science campus. In our department, we've got 22 professors and around 20 other teaching staff, which is maybe a bit of a difference from some US universities, that we have quite a few lecturers and people who are basically their main task is university teaching. And then otherwise we have postdocs and PhD students. The number here with the asterisk next to it is our postdocs and PhD students. That only includes people who are on our staff. And there's a lot of students who have funding from like a research foundation who don't get counted in that number. So probably realistically, it's about double that. Oops. And just a couple things about Finland and Finnish people. You're maybe familiar with the sauna, which is probably the most visible thing about Finnish society that's seen elsewhere. So Finnish people, of course, like going in sauna. They also like spending time outdoors in nature, especially next to lakes, like shown in the photo on the top right. They're also quite fond of personal space. So this is kind of like a joke that you'll see on places like Reddit every once in a while, a picture of Finnish people standing at bus stops, but you could basically go by a bus stop and this is the reality. Like people really space out quite a lot. They would joke that during COVID, like this 2-meter spacing was making people uncomfortable because they had to be closer than normal. So, but that's true. I mean, people just like their personal space, and they also have an odd affinity for buckets. So, I mean, buckets are like multi-purpose things. You can use them to collect berries or mushrooms in the forest. You can store car parts in a bucket. You can put water in there. You can collect fish. You can do whatever. So Finnish people pretty much have like stocks of buckets in their homes, which is kind of also unusual. So why am I here? Well, as Nate mentioned, I'm doing a sabbatical, so I'm here till the middle of next month. And I'm here because I'm trying just to make some connections to people who are interested in stuff related to basically geodata science research and education. I'm just trying to kind of see what people are up to. So I've already had a chat with Nate and Elsa a couple weeks ago and got some idea of what's going on. But this is basically the idea is just to connect. So I don't know that I'll use the whole time, but I'm more than happy if you've got questions along the way to just like stop and talk about whatever. I don't care if I get through all the slides. You can access the slides with the QR code there. So if I don't finish, you can always see them there. And I think you can also get the source code for the slides if you want to see that as well. So point is just interrupt if you have questions, because I would be more than happy to see like get derailed and have a discussion and not finish half the presentation. But in general, the plan is to kind of give you an overview about some of the stuff we've been doing in terms of developing our courses and the teaching we do related to geodata science in Finnish universities. And our target audience for the teaching that we're doing is mainly bachelor's and master's students in geology and geography. So we don't have like an environmental sciences major, at least it's not on our campus. There's a biosciences campus where they have some more environmental science stuff. And we get a few of their students, but our main target audience is geology and geography, bachelor's and master's students. So I'll first kind of talk a little bit about like what our ideal situation is in terms of our kind of teaching and learning goals for the students, and maybe some of the sources of like information, like things we've found over time that we've added to our catalog of what we teach. Then I'll talk about some of the courses we've developed. Basically, all of the course materials that we've been producing are available online. So there's links in the slides to all the course pages where you can go and check stuff out if you want to. We're more than happy to have people share and use our materials, which is really nice. I'll talk a little bit about the tools we've been using as well, because part of it is what material we produce, and the other part, whenever you teach something computational, is how are you doing it? Like, what are the tools you're using? How are the students learning what different kinds of things? And then, like mentioned in the title, some of the lessons that we've learned is what I'll maybe wrap up with, and the challenges that we're still facing because we haven't solved everything. No surprise there. So in our best situation, what we want to do is essentially provide our students with a skill set where they learn the essential computing skills. And for us, what that means is basic programming. So the students that come in are somewhat familiar with programming, but maybe haven't had a first like proper university level introductory programming course. So we teach them Python. I think for geodata science, it's probably the most widely used language, so it's appealing. And at least when I first started doing this stuff, we were being pushed to teach MATLAB, and I don't like the sort of proprietary nature of MATLAB, so we taught Python. We also wanted to teach good programming practices, so things like using version control, stuff that's maybe becoming a little bit more standard now, but at least when we first started doing it, a lot of students weren't even familiar with what version control was at all. We want to teach batch processing because, of course, if you learn to program, part of the reason to write a script is to be able to apply it to large numbers of data files or repeat your processes over and over again. And we want to kind of teach what are the tools that people are doing this stuff for their career, what are they using, so students can like more easily transition into using those same tools in the work life. Part of the motivation for this comes from the fact that all three of us who were listed on the title slide today are pretty much self-taught programmers. And with that comes a lot of mistakes along the way. And well, as we got more experience, we realized that we could have avoided some of these mistakes by finding good materials. So, you know, for a lot of us, we didn't learn version control up front. It was something that came on later after making mistakes like accidentally deleting files and losing months of work. Things like unit testing for developing robust code, good coding practices, so following guidelines like the PEP 8 guidelines for Python programming, and how to effectively debug. All of this stuff is now, I think, a little bit more standard in terms of what's being taught, but it wasn't at the time when we were kind of getting into programming, and we lost a lot of time due to that. A big part of this, at least for me, was software carpentry. So probably some of you have been to their page before. I took a software carpentry boot camp back in 2010, and I was like, oh, wow, this is the right way to do things. And it was quite both inspiring and really useful to have so much of their material available online, which we've certainly kind of, with acknowledgement, shamelessly borrowed from. We've also been taking advantage of some of the materials available on GitHub because GitHub's educational stuff has been growing over time. And now they have some really good pages on things about like using Git and basic ideas about version control that's as good as anything that we could produce. So we're now borrowing a lot of stuff from the Git pages because there is so much of it that's available and it's quite mature in terms of its kind of development stage. And we take some inspiration as well from textbooks. So probably some of you are familiar with Wes McKinney's book about pandas, which is essentially just an overview of what you can do with the pandas library with a little bit of introductory and conclusion stuff. This, for what we're doing in terms of introducing working with tabular data sets, is kind of we follow the sort of McKinney introduction of how things are brought in and has proved to be a really useful resource, not only because the book itself is good, but also because, again, it's available in an online version where you can go and copy paste little code snippets and test stuff out really easily, which makes it a super good resource. We don't teach everything that's in there because it's a pretty big book, but at least for our students, it's really helpful because we can introduce them to things and then they can go and explore more as they want to. So that's been a great resource. And of course, I should mention that we keep up on what people are doing all over the place. So we kind of keep an eye on what like Earth Lab stuff's been developing. We've been like for years just trying to follow what people are up to. Twitter was really good for this maybe 5 years ago when like the academic Twitter was thriving because you just see stuff online. People would post regularly stuff they'd been working on or cool new things they had done. And it just made it really easy to follow what people were developing. And it felt like there was a good sense of community that everyone was kind of open to and sharing a lot of stuff. It feels a bit of a shame that that's not really the case anymore. I guess Blue Sky is kind of trying to reestablish that same thing, but it's a little slower to get up and running, at least. Yeah. So it's good. But yeah, I mean, basically through social media, we were able to keep tabs on like what Earth Lab was doing, what other groups around the world were doing. And that's also been great because, like any of this stuff, when people are sharing things online, it feels like everybody kind of gains something from that kind of approach. So yeah, I'll say a little bit then about some of the courses we've been developing. And our first maybe foray into teaching Python was this course called Python for GeoPeople, which we taught in 2016. I think we actually did a short course version of it the year before, but I couldn't find the materials for that one. This is still up on GitHub. And this is basically like the little image on the right side. That's what the page looks like because it is just a README file for a GitHub repository. The interface to the course was a little bit simple. And, that was our first attempt to trying to get a lot of this stuff online and accessible to a broad audience. So we basically just put everything into README files, and then there were subfolders with other README files and markdown things in there. But the point was to introduce students to Python programming, both the kind of syntax of programming in Python, but also the kind of concepts of like, what is a loop? What can you use it for? What are conditional statements? These kind of things. So to develop both the ability to program in Python, but also how to think a little bit like a programmer. And at the same time to introduce Git and GitHub Classroom. So we were, I would say, kind of building a template for what our later courses would follow. Again, our target audience was the same kind of bachelor's and master's students. And in this case, the students were working with, I would say, what feels now like a really clumsy interface. So we had a cloud computing resource available to us, but the students were doing basically like remote desktop connections to a cloud server and then opening up a virtual desktop in Linux and launching either the Spider IDE or a Python interpreter. And by comparison, I think to how we're doing things now, it feels rather old-fashioned. But it seemed to work, and it was something where we could at least control the environment, so we didn't have to worry about students having different versions of Python libraries on their own computers, which is just an absolute mess in terms of trying to get up and running. So the Python for Geo people became what's now our GeoPython course. So over a few years, I mean, even in 1 year, we jumped from having a README file to a proper web page, which was a big improvement in the interface. But it incorporated more or less all the material from the Python for Geo people and just a little bit more polished thing. And this is more or less what we've been chipping away at for the last 10 years, is just gradually improving this course, enriching the material, improving the material based on student feedback. And it covers essentially the same stuff that was in terms of like the programming introduction, same stuff that was in this Python for Geo people. But now we also go a little bit into more like what are the modern tools that people are using and try to get the students working in practice in like an environment that might be similar to how they would work outside of the university. So I'll talk about some of the tools that we're using in a little bit. But just to give a bit of information about the course itself, so it's most of the courses at the University of Helsinki run for either 7 weeks or 14 weeks. The preference actually is for these kind of 7-week courses because it's easier for students to schedule them. So for us, that means we have a 7-week course with a 3-hour lecture, and then we have a couple times a week where we have our course assistants around to provide student support to work on exercises and things where they want extra help outside of the class. As I've kind of put together, we introduce basic programming ideas. We do data analysis stuff with pandas. So that's our kind of still our preferred approach for right now. So the first couple weeks, they're basically just working, typing in, making little lists, copy, pasting example code from different places and playing with it. And when we start working with pandas, then they start reading in data files. And I think for a lot of the students, it gets a little bit more complicated, but it also gets more exciting because you start working with real world data. So we do that, and then we wrap up with some stuff on data visualization because, of course, once you can read in a data file, it's only natural to want to look at the output. Given our mix of students, we try to use climate data as a kind of common uniting theme. So, both groups of students intuitively have some sense of this stuff, and we try to find examples like the news article that's shown on the right of anomalous things that have happened in the last year. So if we had a really warm month, it's often in the news, especially these days, that like we've got the warmest April on record. Then we go and we'll pull data from someplace and we'll say, can we demonstrate this ourselves? Let's go and take the data from this weather station. Let's calculate the average for all the Aprils going back 150 years and then sort and see which one was the warmest. And I think it feels quite fun to them, because we try to keep it a little bit fresh with these new data sets. It makes a little extra work for us because sometimes we have to kind of reorganize the exercise a fair amount just to make it work. But the more that we're doing this, the more we have kind of examples that we can pull from in the past. And sometimes it's, 2 years ago, it was the warmest April, and oh, look, it's the warmest April again this year. So you just take the new news article and then update the data file. So, it is in some ways not that painful. For the way the course operates in terms of like the grading and things like that, they basically have 7 exercises that they work on, and that accounts for 60% of the grade, and then they have a final exercise. And for the exercises, it's usually something like 2 to 4 problems, and it might take them 4 to 8 hours a week to work on it. The first couple are definitely on the less than 4 to 8 hours. And then toward the end, when they start working with pandas and they really have to start data aggregation and stuff where it's a little bit more challenging to understand exactly what's going on, it ends up taking more time. But we do things like, classifying temperatures. So read in a bunch of temperatures from some Python list and then just sort them, like whether it's hot, cold, warm, whatever, just to get a sense of like not only the idea of how to read in and interact with this data, but also a sense of classifying things, because it's a pretty typical kind of operation. And I think I'll sort of talk about the format, but as you can already tell, this is a Jupyter notebook that they're working in. And we record our lesson videos. So we do this in terms of like, especially for the GeoPython course, we do it as kind of like a live coding environment. So basically just record the instructor as they're going through the lesson, typing things in, and it lends itself nicely to students being able to ask questions. If you want to sort of see a more complicated example, they can just ask and say, hey, can you show us how to do this? Or I don't understand this thing. And I think it's fun both as a teacher and perhaps for the students that it feels more like it's not just following a script entirely. At least for me, I find the more that I teach, it just starts to get kind of repetitive, and it's easier to stay more engaged when you feel like there could be a question at any moment where somebody wants to, add something to what's in the course materials. So we do that, and then yeah, we record the videos and put them online. So if you're curious, you can also check out the YouTube videos just to see how we introduce things and teach. The drawback with this is that not everybody shows up in person because the students know they can watch the lecture video. I'm still pretty pleased about half of them turn up. So given that, it's like Monday morning at 9 or something like that, which is not the earliest start, but feels early for a lot of students. I'm happy that half of them show up. And for us, what that means is, we've got something like 40 or 50 students who are there in the room, which again feels like we've got a critical mass where people will, we're not just talking to empty space. And for us then, like for the course, we have myself and another instructor, we kind of co-teach it. And then we have something like 4 course assistants typically who are helping out with mainly the grading for the exercises and also being there to answer student questions. From the GeoPython course, we then have 2 options. So for the geography students, they can go on to this automating GIS processes course. We don't really do anything geospatial in the GeoPython course. So like this is then their first opportunity to start working with geospatial stuff. So they get introduced to Shapely and different kinds of like vector objects you can create with the Shapely library. How to use GeoPandas. So they already know something about pandas, but now they bring in this kind of geospatial piece to it. More kind of sophisticated things about classifying data, more visualization stuff, especially producing interactive maps is always a very popular thing because it's really fun. And then they end up doing a little bit of stuff with raster data, but it's very much skewed towards kind of vector-oriented things. Personally, as I'm a sort of geologist by training, if I was to teach it, I probably would have it more like a 50-50 balance because I'd want to do raster stuff with elevation data, for example. But it makes sense. The person who was originally designing this course was doing stuff with like transportation data and mobility of people in cities, and that's largely vector data. But yeah, they do things like make maps like this. So this is an example of just the locations of trains and metro stations in Helsinki. And the structure in terms of like the learning environment is very similar for the students to the GeoPython. So it's an easy transition to come into that course. For the students who come, if they've done another Python course somewhere else, it might take them a little bit of time to get up to speed just because they might not know version control, but we have the materials online so they can at least go back and find that stuff if they need to. And similarly, the videos are recorded and posted on YouTube for this course. And again, you can check those out if you're curious. For the geologists, they get to come with me on the turn to quantitative stuff. And so the quantitative geology course that I teach basically assumes that you know everything in the GeoPython course, and then we introduce NumPy at the beginning because we need to do some stuff with vectors. Essentially, the course is about translating equations into Python code. So we go through a series of different equations, starting with things that are relatively simple, like the basic geostatistics. We do things like calculate the mean value, like make a function that'll calculate a mean, make a function to calculate standard deviation, just kind of build the foundation of these things that are going to be applied in other places. And then we go into different like relevant geoscience equations that they might be interested in. And in the end, throughout the course, basically what we're doing is we're building a library of Python functions. And at the end of it, then they have this application where they read in data file and they run this numerical model to kind of make predictions to compare to their data. And I think, to me at least, it seems like it's a nice thing that you've got a good example of like a library of functions that you made. You've got your notebook where you've got all this sort of explanation of what you're doing with your workflow. And I think it ends up being a nice combination overall. So they do stuff variety of different applications. This kind of viscous flow down an inclined plane would be like ice sliding down the valley of like a glacial valley. Again, the learning environment and everything is meant to be very similar to the GeoPython course. Maybe the difference is I don't do live coding for this part. So I'll kind of introduce things at the beginning of the class with maybe 15 or 20 minutes of kind of introductory lecture. And the rest of the time they kind of hang out and work on the exercise for that week. There's not really, I mean, we could go through things in more detail, but I've had the request from the students to kind of try to do it similarly, but it feels to me like it just sort of sets up more nicely to say, like, here's basically an extended introduction to the lab exercise for this week, and then I'll hang out here, you guys can get started, and if they have questions, then like they can ask. And since I'm there, sometimes we do end up, going, like, I'll plug my computer in and we'll go over something for 15 minutes to, if there's a kind of common point of confusion. But similarly, again, the videos are on YouTube, and if you're interested, you can have a look at those. Beyond that, some of my colleagues, especially Henrik Itenkinen at Aalto University, he's been developing even more of these courses related to spatial data analysis and sustainability. So these could be things that would be of interest. I think they're a little bit shorter in terms of number of weeks. They're kind of smaller courses, and I think at least these two are kind of quite closely related to each other. I think one is meant to be taught as a short course, and the other is like a 6-week course because of, the Aalto University does a 6-week thing instead of 7. So their courses are a little bit different in terms of the structure. But there's also a couple websites here that might be of interest. So the spatial data science with high performance computing is actually, it's not taught by a single Finnish university, but it's a collaboration between several Finnish universities, and then I think the Finnish Geodetic Institute and Finnish Meteorological Institute. So they've been developing materials for dealing with bigger data sets. So if you're into big data stuff, this could be potentially something that would be of interest. And then Hendrik wanted me to highlight their geospatial challenge camp as well, because this is something where they're basically trying to engage with young, like university students, master's and bachelor's level, to come up with innovative solutions to a variety of different geospatial challenges. I can't remember what the theme was this year. I tried to think of it before coming over. But you can go and check out the webpage and you'll see what their theme was. I think they put the students together in teams, and then as a team, they're kind of tasked with coming up with a solution to some kind of challenge. But it's again, more info on the webpage there. I think, so I'll say a couple things now about the tools that we use. Some of them are perhaps not going to be a big surprise, but essentially, as I mentioned at the beginning, our aim is to try to provide the students with examples of the tools that you'd be using either in research, like in an academic setting, or industry, and that we've chosen things that are kind of complementary to one another, which is what people do in real life as well. Our expectation is not to see every student launch themselves into a career as a Python programmer or data scientist. Of course, that's not realistic. But what we found is that for the students some students just take it and run with it, and that's great. They really get into this stuff, and that's what they end up doing, is going into data science or something like that. But even for the students who don't, it's great because they understand a little bit more about like what's behind some of the data that they're working with, and they understand ways in which to interact with things. They can talk to people who are the kind of more software-oriented people because they understand a little bit more. And at least the one colleague who's working at the Finnish Environmental Institute was saying, some of the former students who've come there haven't been doing stuff with their coding, but they really understand the guts of what's going on, which has been really helpful. And as I noted before, sometimes it takes the students to get up to speed with our environment. It might take them a couple weeks, but that's because we throw a lot of tools at them. And of course, it takes a bit of time. So I guess, is everybody here familiar with Jupyter notebooks? More or less? Yeah. So they're pretty much the standard thing these days. So we had been teaching Python with the Python interpreter, and it felt like I was actually the curmudgeon who took a while to come around to the idea of teaching with Jupyter notebooks. And now I'm fully converted because they are definitely super, super useful. And both for making our exercises and like the teaching materials, we basically do everything in Jupyter notebooks, and then it's rendered as a web page. So that's been really powerful and helpful. I think the students really like the idea that they can have nice documentation of what they're supposed to do and then a space to do it. And you don't have to be jumping back and forth between different web pages or whatever. So that's been really super handy, and very happy to be working with Jupyter. And we're lucky because we have at the Finnish, the IT Center for Science, which is I guess it's a private company, but it has a contract with the universities that provides university researchers and teachers with free access to their resources. They run a service where they host basically kind of a Jupyter Lab server where you can set up custom Docker images for those who use or know what Docker is used for. You can customize your environment for whatever course and upload it to their system, and they then allow you to run Jupyter notebooks on their servers, and any Finnish student at any Finnish university has automatically access to those resources. So they just sign in with their normal university credentials, and then they can launch the notebooks. That's super nice for us because not only is it a really good and reliable service, but it also provides persistent storage. So the students can keep some files there as long as the image is alive. They can have files they're working on there. If they lose their internet connection or their time expires, they don't lose their work, which we had problems with earlier on in the course when there wasn't persistent storage. Like students would really be disappointed if they were working for like 6 hours on something and their cloud instance died and they lost the work they hadn't saved. We tried to sort of spin it so that like, well, it's a good opportunity to remember to push things to GitHub, but like, of course, that doesn't really undo the pain the students experienced. So that's great. We also have been using Binder. So because everything's available online, we do want to have people who just happen to follow and like stumble upon the course, that we want to have them have an opportunity to be able to tinker with things. Binder's okay. Probably some of you have some experience with Binder before, and it's nice. It's a free service, but there's no persistent storage. And if you leave your notebook alone for more than about 10 minutes, your connection to the server will be terminated. Sometimes you can recover what you're working on, sometimes you can't. And that can be, of course, a little bit frustrating. It's also really hard to work with bigger data sets on Binder, just because the resources are meant to be shared by a lot of people rather than like really big resources for individuals. So we provide the option, but even some of the lessons we tell the students, like you can't use Binder for this one because the data files are too big and you won't be able to do anything with them in Binder. We're hoping to switch over to using JupyterLite for those who've been kind of following what's going on with that. But I was talking to somebody a couple weeks ago here who was visiting, who was like one of the Jupyter developers, and they said like there's still some kind of significant things they're trying to get resolved with JupyterLite before that's a good option for us. So there's a lot of libraries, for instance, that are not yet able to be used in JupyterLite. But that would basically be something that's a kind of server-free solution. The Jupyter server would run on your own machine, and you don't even know. You just kind of click a link and it opens up and it's running and storing things like in the browser cache. So it would be really cool when that eventually comes, because then we can move away from Binder. Mentioned already that we teach Git in GitHub and GitHub Classroom. So, version control stuff using Git, I think that's pretty standard these days. Probably some of you have seen this comic before and experienced exactly this thing. I think it's a great example of exactly how a lot of people work with Git. So, of course, the idea is you want to track the changes of things that you're working on. And that's the main reason that we introduce it. But we also try to highlight the fact that, this can be helpful for debugging things. If you've tracked your changes and something broke all of a sudden, you can go back to the previous version and figure out what did you change and why did it break. And also that you can collaborate on things. So, that's kind of a big piece, especially the GitHub part of the equation. Keep doing that. For GitHub, we also use this GitHub Classroom setup, which some of you might be familiar with. It's great for like distributing exercises, because you can just have a link where a student can click it and then they can make a copy of an exercise template and start working on it. And that's handy. We usually set it so the students' exercises are private, so they also don't have to be kind of embarrassed if they're not wanting to share the code they're working on with the whole world. But this is also a really good way to say, like, but not only are we going to tell you that using version control is a good idea, but we're going to force you to commit your changes and push them to Git, because that's how you're going to get assessed, is turning things in by pushed changes in GitHub. And we've been using this JupyterLab Git extension, which is also, if you haven't seen it before, quite handy, because then the students don't have to leave JupyterLab to push their changes. So they can basically make some changes to whatever document they're working on and add a commit message and push the changes inside JupyterLab, or they can clone their template repository and start working. So they can stay as much as possible in the same working environment, which, again, for those of you who are doing this stuff regularly, is probably how you're working. I'm still old school and like to do Git stuff on the command line. So I don't use the plugin myself, but the students seem to be quite happy to not have to go to a terminal to do like these clumsy Git commands to update what they're working on. And yeah, I mentioned already GitHub Classroom for distributing exercises, and so I don't maybe need to say anything more about that. For communication, we've been using recently Discord. So we like to have some kind of team type communication platform for the students to interact, both with each other. So a lot of times students will ask questions inside Discord, and then other students will answer the questions, which is great. But also then it's easy for the busy teachers to keep track of things that are specific to this course, because you can see if there's activity in the Discord for the course. We've used Slack before, but Slack changed their business model several years ago so that things that were older than 90 days would not be visible. And of course, for us, that is a bit of a problem when we start a course in September, and sometimes the students might be late in turning things in, and all of a sudden messages start disappearing. So Discord's been a little bit better for that, but it's more or less the same experience, I would say, from the students' end. We also use this Pressimo system, which I don't know if you would have encountered this one, but you can kind of do live polls during class. I know there's lots of other options for doing this type of thing. But we'll ask them questions during the lessons, for example. We'll have something like, with this list of animals, which one of the ones is it indexed -2? We'll have introduced something like that, and it's just kind of a quick way to see, did you guys get it or not? And I think the students also like having that pause for a second where they stop listening to us talk and get a moment to think themselves. So that's been quite handy. I think they have for like a paid version of it, but also, I don't know, for university use, it might be that it's you can use it without a charge. But I know other options for that as well. And for grading, we've been using NBGrader. It works okay for us. I think the sort of general platform's nice because you can design the exercises like it's kind of pixelated GIF I took from the NBGrader website. You can design things in a nice way, so you can have your template with your solutions for the instructor inside the document, and then there's a command to basically make a student copy of it where it strips out all the solutions, and then in a sense, you've got a very easy way to grade things. Some of the questions can be automated in terms of the grading, which is also handy. But the problem with using GitHub Classroom is that NBGrader kind of relies on using NBGrader to also distribute the exercises and collect them back. Ideally, that's how it works, because what happens then is the students have a button where they can click to validate their solution and see whether or not they've got the right answer, which they can't do, at least for our current setup with NBGrader. So that's been a pretty regular complaint. The students want to be able to check and see if they're getting the right answer as they're working through their notebooks. And so we're now working on switching everything over to using PyTest and using GitHub Actions, so that when the students push a change to their exercise, it automatically runs tests and tells them, out of the points that are available, how many points did they get, and also indicates where they had problems on the solutions that they're working on. So I think I'm hopeful that will be an improvement, but it's been something that we've had a student working on for a few months to kind of develop and migrate us away from using NBGrader. I think it will be a better solution in the end, but we'll just see whether we can get everything kind of migrated easily. So maybe a couple things about our teaching philosophy. So generally speaking, both the University of Helsinki and our kind of approach in the course is that we are in favor of using these kind of generative text like tools like ChatGPT or Gemini or whatever you want to use. But it's, of course, challenging when you're introducing students to programming at the beginning. You don't want them to rely on those tools entirely and say, okay, this is how we're going to write our code, is we'll just ask ChatGPT to do all this stuff. And they never develop any intuition to be able to look at the code it produces and understand, yes, this is right, or no, this is not. So we want to introduce them to how to do this properly. We want to introduce them how to write good prompts to get like meaningful, useful code out of it. But we do this by basically controlling in the exercises. We have some parts where we flag with this text LLMs okay, which means that they're free to use a language model to produce the code for that part. But we ask them then to give us a list of the prompts that they gave and an example of like what the code that was that came out of there. Just so we could see how did they iterate on what they were working on, because some cases they'll get code that doesn't really do what it's supposed to. And we want to see kind of how they were thinking about it. But this is tricky. I think this is a problem a lot of people have been facing, and I don't know that we have a good solution, but at least at the moment, we're kind of trying to say there's some parts of the exercises that are okay and some parts that aren't. We also pair the students up. So for the GeoPython course, especially when there's new programmers, we try to match up a more experienced person with a total newbie. We do this by we have a pre-course survey that we send out and just ask people to kind of rate their level of programming experience. And that helps us to match people up. And we do it in I would say, fairly traditional pair programming approach, where like there's one person who's the driver, who's the one who has their hands on the keyboard, and the other person's the navigator, who's basically looking over their shoulder and checking to see, as the person's working, catching all the little typos and things like that. And that seems to be working reasonably well. The students' feedback on the paired programming thing has been good. And the really nice thing for us is because they're paired up, they only turn in one exercise for two people. So we have 50% less stuff to grade, which is, of course, welcome as well. So as I'm running low on time here, I'll give a couple things about some of the lessons we've learned. So maybe the biggest and most visible one is that the students really apply what they learned, especially in these introductory programming courses. We see it now, like students that were doing stuff in Excel years ago are now doing almost everything in Python. And that's probably the coolest thing to see. Of course, there's like the outstanding examples of students who go on to be like Python wizards and produce stuff that we even as teachers can't do. But it seems like this has become popular and they've understood essentially the value and the benefit of learning to program. And even when we're not asking them to do stuff in Python, it's showing up in Python, which is, I think, to me, super cool. As I mentioned about the pair programming, the students basically, they seem to like it quite well. It's the highest, we ask them like in the midterm feedback survey to rate different things. And that's usually the highest score overall for like the thing that's most beneficial in the course is the paired programming. Not everybody likes it, but for a lot of the students, they seem to. We start them off in the first 4 weeks. We say, okay, you have a partner. And then after that, they can negotiate with us if they want to go their own separate ways. And occasionally we have some students who, for one reason or another, if they're working and they can't be available, then they might fly solo the whole time. But generally, that's been pretty popular, which has also been nice, as mentioned about the grading thing. And I think one of the things that's been a kind of challenging lesson that we found is just trying to find the balance between what's difficult or challenging for the new students and what's boring for the more experienced people. Finding that balance has been kind of difficult. We've started adding in optional exercises for more advanced students so they have something to kind of stimulate them. But we still get feedback pretty regularly. Some students are, this is way too hard, and other students are like, I'm bored. So we're still trying to find a good balance between those things because it's not easy. We hope that like pairing them up where the more experienced person could talk to the new person would be another way to like get them to engage in a different way and think about things. And as they say, the way to sort of find out what you know about something is to teach it. So we tried to sort of make that argument, but still we get feedback from some of the more advanced students. They want more challenges. Then for the things that are kind of visible challenges we're facing, one of them that's challenging for us is we get a lot of requests from people who want to take our courses and get a certificate for completing it, who are not Finnish university students. And we've been trying to figure out what's a good solution for this, because we basically don't have resources ourselves to do the grading and to do like the assessment. In a sense, we're leaning towards maybe making a fully automated version of the course where you can do all the exercises and get all the kind of points by just passing the automated grading tests. But of course, with that comes some potential for abuse, and we don't want to kind of dilute the value of the course certificate if we were to issue one, because you can basically just dump the whole course into ChatGPT and get all of your solutions back. So that one's tricky. Our automatic grading system is pretty good in general, but writing good tests is not easy. So we've had students who've been frustrated sometimes that like they didn't get the points from the automated grading. They actually came up with the right solution, but they had something weird like an extra column in their data frame that caused the test to fail. So it's really hard to write good tests that checked for the right answer, but also don't penalize the students if they've done something a little bit unexpected to get that right answer. So this is one where we've been iteratively trying to improve our tests, but it still, again, takes time, and we lack some capacity for that. Then again, as I mentioned, with the like ChatGPT type tools, they're great to introduce the students to, but we don't want them to kind of compromise their ability to actually look at code and understand what it does, because they're never forced to actually think about the whole construction of some code snippet. They only sort of look at a ChatGPT thing and go, yeah, this looks good, and then move on. So that one's, I don't know. There's still, that's something that we're dealing with. And lastly, about our exercises, they're pretty structured. If you go and you happen to check out any stuff that we have online for the exercises, I mean, they are really, I would say, almost too structured and rigid in a sense. And in some cases, then the students feel like they don't have much creativity to come up with their own solutions to the problems. With the automated grading, it feels like you want to have a test that checks to see, did you do this little step? And then did you do this little step? But the problem with that, of course, is that then you lock into this structure of like, this is the only way to finish this exercise, which feels a bit like that's not really how programming works. I mean, with anything, you've got lots of different ways to do the same thing. So that's more or less, I think, where I'll leave things for now. I do want to acknowledge a few people. So the GeoPython course, especially, we've had several different teachers who've come through. Kamir Hassanzadeh is now the co-teacher who's teaching with me, but didn't contribute to the presentation. But we've had a crew of different teachers who've contributed to developing the materials for that course, especially, and a whole bunch of course assistants, without whom we really wouldn't be able to do a lot of the work. They're really good about providing the students with timely feedback, and also get kind of going the extra step that we wouldn't have the time to go, about like giving them some direction about here's what you did wrong, or whatever things that I think the students have found really appreciated. It feels like personal feedback that's actually kind of a little bit more detailed, and that's why we have a whole crew of people there. And as a last thing, I'm of course more than happy to take questions and things like that, but I also want to shamelessly plug our online textbook, Introduction to Python for Geographic Data Analysis. It's about 2/3 complete now. It's more or less a GeoPython course plus automating GIS processes course in a little bit more polished package with some case studies. And the case studies are the part that are still under development. But if you're interested, you can check that out too. If you want to, at some point, you can always buy a copy of the book when it's finally published. But everything in the book is available online, so you don't need to do that. You can just go check out the webpage, and I'd encourage you to do so. If you have any feedback, of course, we'd be more than happy to have comments in GitHub, for example, with suggestions, feedback, whatever it might be. With that, I think I should stop because I'm kind of already going a little bit beyond my time. But I would really be happy to take any questions you might have. And yeah, thanks for your attention.